Wasabi, you guys. Welcome to Integration Bee Training for Advanced 11.2, which means that we're still into complexifying the integral, except that in this section, we're going to be dealing with trickier manipulations. Okay, so let's go ahead and get started. Okay, so we have this amazing MIT integral here, and I think the proper way was to use trig identities to separate this and then integration by parts. However, that's gonna take way too long, and it just looked like an ugly mess. So instead, we're gonna complexify this, okay? But how on earth are we going to complexify this? Right, so we have cosine. We have this cosine here. So because we have cosine, I'm going to take the real part of e cosine of x, and now that cosine is now e to the I. Instead of cosine of x, it's cosine of x plus sine of x. So instead of e to the ix, it's e to the I of x plus sine of x. Okay, so that's how that works. And now, what we have here is now we have cosine of x plus I x plus sine of ix. Sorry, I of sine of x. Okay, and there's something suspicious here. There's something very suspicious here. Cosine of x plus I sine of x, that's e to the I of x, isn't it? Yes, it is. And we have e to the I of x here. Oh, wow, would you look at that? Let u equal e to the ix, then du is equal to I e to the ix. So now we have e to the u du of 1 over I, pretty much, which is technically negative I. And so now what we have is we have negative I of e to the u, which is e to the I x. Okay, and now our job is to find the real part of this. Okay, complex algebra time. So if I e to the I of x, this is cosine of x plus I sine of x. Okay. However, even though we have e cosine of x times e to the I sine of x, remember that e to the I of x is equal to cosine plus I sine of x. So e to the I sine of x is equal to cosine of sine of x plus I of sine of x sine of x. Sorry, sine of x. Let's see, if we simplify this, if we distribute this, that's going to give me an imaginary part. If I distribute the second term, that's going to give me the real part. Okay, so I found the real part. That's going to be sine of x. Yep. So our answer is e to the power of cosine of x sine of x plus c. And this is our answer. Okay, very tricky manipulation, right? We literally had to complexify, and then this nicely turned out to be e to the I of x. And then, basic u substitution, and then our goal is just complex algebra, right? Split this, and then split this with using the e to the ix formula, right? With cosine plus I times sine of x, right? And we had to do that again twice. So again, the trickiest part is just the complex algebra. You just have to get very comfortable with it. Okay? So we have this weird, ugly looking integral here, right? A bunch of e to the x's, cosines. It's a horrible combination. So let's go ahead and complexify this. If I turn it into real, we get the integral from e to the x, e to the x, and then we have e to the I of this, e to the x plus, and then it's technically, you know, the same thing. You just split it, real part into another real part. I don't think it matters. So I think we get this. And now notice that we can do a u substitution on the left side. We'll let this u equal to e to the x. And on the right side, we'll let w equal e to the x. Just e to the x. So now what we have, I'm just going to be lazy just a little bit. So we have this du, e to the iu, okay, plus, and then over here, we have e to the x, e to the I w, plus another w. So we technically have, let me just rewrite this, w1 plus I dw. Okay. Cool. So now what we have is, you know, this is just negative I e to the iu, and then this is the annoying part, e to the w, 1 plus I. Okay, so now what? Well, we have to conjugate this, and then we have to turn this back. Right? So, I mean, we know that this is the imaginary part, technically. You know, e to the iu is cosine plus I sine of u. So we know that we're going to have a sine of u here. Okay. And then, let's see. Because u is e to the x. I'm just making sure I'm doing this correctly. I'm sorry. I believe that should be negative, right? Oh, no, that is positive, right? Because I square cancels out that negative. Yeah, okay. I was a little iffy for a second. I'm like, wait, that's not right. But no, the I square cancels it out. Here, it's just conjugation. So we have like 1 minus I over 2, and then e w1 plus I. And of course, we have to simplify this even further with that I here. So we have e to the w, and then cosine of w plus I sine w. Okay, so now what we have is we have the real part, e to the x, plus, and then the half. For the half, we have the e to the x cosine of e to the x. And then for the negative sign, the I squared cancels out that negative. So we actually also have sine of e to the x as well as our real part. So this whole thing, this nastiness here, this is our answer. Okay? Alrighty. Okay, last integral. We have this case here. We have like a Gaussian times sine of x squared. Okay. Let's complexify this. Cannot speak now. So when we complexify this, we have e to the negative x squared, and then times e to the ix squared dx, right? And this can equal to from 0 to infinity. We can easily simplify this as the negative x squared, and then from 1 minus I dx. Okay, so now what we're going to do is we're going to let u equal let u equal x times the square root of 1 minus I, right? So now we have, after the u substitution, we're forcing this into a Gaussian integral, like that. And now we just have to deal with complex algebra. That's it. That's the most annoying thing to deal with, is the complex algebra. I'm going to actually conjugate that. And this would be square root of 2, square root of 1 plus I. So after conjugating it, we're going to go ahead, let's see, how do we simplify this? So the most difficult part is this right here, right? So 1 plus I, let's see, 1 plus I, if we think of this in terms of cosine of, let's see, cosine of something that equals to 1, cosine of 0, but then sine of 0 is 0, so we can't do that. Ooh, here's what we can do. We can actually make this into root 2 plus root 2 over 2. So that's pretty much like multiplying root 2 times root 2. Okay, right? Because this is technically 1 over root 2. But what I'm doing is now this becomes like cosine of pi over 4 plus sine I times sine pi over 4. So now we have I pi over 4, like that. So much better. And now, what we have now is that we have the imaginary part of, let's see, this would be square root of pi over 2, root 4 of 2, and then e to the pi over 8i. Okay? So the imaginary part like that. Alright, disgusting, I know, nasty. And then so the imaginary part of this is sine, and so we technically left our answers in the real part. So our answer is 1/2 square root of pi over the square root of 2, and then sine pi over 8. You could, it is a real number, so you are allowed to just leave it like this. Okay? And that is your answer. Alright. Ooh. Nasty. Yeah, complex algebra. The hardest part. You just have to get very comfortable with complex algebra. But it's okay. I'm giving you as much types of cases as I can. But for now, I think this is pretty much it. Okay? Alright, so practice that. Get comfortable with complex. If you really love complex numbers, then you must really like this technique. I'm not a fan, as you can see, but it is something that we do have to conquer for some integrals. So yeah, thank you guys so much for watching, and I'll see you guys in the next part.